Hello, practice questions on representing motion, position, time graph. 1. When did the runner described in the graph reach 15 meters beyond the starting point? From the 15 meters on y-axis, we draw a horizontal line until we intersect with the slope, and then we draw a vertical line until we intersect with x. So the answer here is 3. C. 2. Something is an object's position at particular instantaneous position. 4. The graph represents a hockey puck gliding across a frozen pond. How far did the puck move between 0 seconds and 4 seconds? So from 0 to 4, we need to draw vertical line until we intersect with the slope, and then horizontal line to get the answer. So the answer here is 80, which is D. 5. The position time graph below represents a motion of an object. Which parts of the motion did the object have negative velocity? The negative velocity here, that means we're moving downwards or towards the negative y, which is this direction. So the answer here is A and E. So it's A and E, B. 6. A motion of a car is represented by the position time graph shown below. At what time was the car at position x equals 50 meters? So here 50 meters, so that means 0, and again 50 meters here, which is approximately 35. So 0 and 35. 0 and 35, so B. 7. An object moves away from a motion detector with a constant speed. Which graph best represents the motion of the object? As the object is constant with a constant speed, so that means we draw a straight line from the origin. So this one is the right answer. So the right answer is C. Question 8 and 9. The position time graph for two objects is as shown below. At which position and time did object 1 cross object 2? So object 1 and object 2 intersect at this point, that means at 2 seconds. And 10 meters. 10 meters and 2 seconds, so the answer is A. 9. What is the distance between the two objects as 4 seconds? At 4 seconds, here object 1 is 5 seconds, and here object 2 is 20 seconds. So 20 minus 5, which is 15 meters. So the answer is C. 10. The figure below shows a graph of the position x of two cars, C and D, as a function of time, t. Which of the statements about these cars must be true? First one, the cars meet at time t equals 10. Yes, that's true. So no need to read the rest of the answers, so the answer is A. 11. The motion of a car and a truck along a straight road are represented by the velocity time graphs in the figure below. The two vehicles are initially alongside each other at time t equals 0. Okay. At time t, what is the true of the distances traveled by the vehicle since time t equals 0? Here, to get the distance from velocity time graph, we need to get the area under the slope or the area under the curve. So that means that the truck, which is the area of a rectangular, covered more area, more distance than the car, which is the area of a triangle. So the answer is truck covered more distance. So let's check the answers. Here it's D. The truck will have traveled further than the car. Answer the following questions. 1. Refer to the diagram below to answer questions A to F below. A. What is the position of the object A? A. What is the position of the object at 6 seconds? Here, at 6 seconds, which is this point, we draw a horizontal line and then to Y. So the answer is 9 meters. B. How much time has passed when the object is at 6 meters? At 6 meters, we draw a horizontal line and then vertical line. So the answer is 4 seconds. C. How far does the object travel for every second it is in motion? So for every second, it will cover approximately 1.5 meters. At 2, 3, so at 4, 6, so that means 1.5 meters. D. If the object continues at this speed, when will the object reach 18 meters? So from the slope, we can say that the velocity equals distance over time, which is, because it's a constant motion, so we can say it's 6 over 4, 6 over 4. So that means 1.5 meters. Now we need to get the time because it's asking about when will, so we need to get the time. And we know that velocity equals distance over time or displacement over time. Here it doesn't matter now here. So we need to get the time. That means that time equals distance over velocity equals, so the distance here is 18. The velocity is 1.5. So the answer will be 12 seconds. E. Where will the object be after 300 seconds? So here we have the time and we need to get the position. So the position from the same triangle here, the position is V times T. So X, or the position, equals V times T, which is equal to V is 1.5. We already calculated it before. So 1.5 times T, which is 300. So the answer would be 450 meters. The position time graph below represents the motion of two joggers. Which jogger has a higher speed, and explain why? So here, if we take a look at the drawing or the graph, we can see that the red jogger has a steeper slope than the blue jogger. So we can choose the red jogger, and we say because the slope is steeper, or we can say because the red jogger covers more distance in less time. B. Will the blue jogger catch up to the red jogger during the motion shown in the graph? How can you tell? So here, from the graph, we can say that no, the blue jogger will not catch up to the red jogger. Why? Because the slopes are getting farther apart as the time increases? So the answer is no, because the lines or the slopes are getting farther apart as time increases. How far apart were the two runners at t equals 2 seconds? So here at 2 seconds we get the position of the blue sugar, and then at 2 seconds we get the position at the red sugar. So it's 4 minus 2. So that means 4 minus 2 equals 2 meters. Thank you.